Welcome to all. The third session of the solution to the TRB-TN Polytechnic lectures, Electrical and Electronics Engineering paper, which is conducted on 11th December 2021. In this session, we are going to see the Part B 2-mark question solutions, detailed solutions. Let's begin. First question, the Fourier transform of signal del of n is. So this is the direct formula. So answer for this is B. Moving into the next question. A 16-stage impulse voltage generator has a stage capacitances of 0.125 microfarad and charging voltage of 200 kilovolt. The energy rating in kilojoule is. Solution. So n is the number of stages. In this question they have given 16 stages, and stage capacitance C they have given 0.125 microfarad, and they have given that charging voltage of 200 kilovolt. So source voltage is 200 kilovolt. So now nominal energy stored. Nominal energy stored is of C1 P square, where C1 is what? C1 is C by N, that is the discharging capacitance. V is the nominal maximum voltage. V is V is nominal maximum voltage. Maximum voltage. So this V will become N times the source voltage. Substituting this, now the energy stored will become, in this C1V, if you substitute, of C1 will become C by N times V become NVS. So V square becomes N square Vs square. So this will become of C N to Vs square. So when you substitute these values, of C will become 0.125 micro into N is the 16 into Vs is the 200 kilo whole square. Now this E becomes 40 kilojoule. E becomes 40 kilojoules. So answer will be option C. Moving into the next question. When high potential is to be measured using a potentiometer, dash is used. So when you want to measure the high potential, you will use a ratio box or voltage volt box. So answer for this is option a ratio box or a voltage box. Moving into the next question. The open loop transfer function of unitary feedback control system is given 10 by s into s plus k, where k is a variable parameter. This system will be stable for the value of, we need to calculate the gain range of gain k such that system becomes stable. So solution will become solution. So write the characteristic equation 1 plus gh equal to 0, 1 plus gh is 10 divided by s into s plus 2 into s plus 0. Next, when you rearrange these things and all, you will get s cube plus k plus 2 into s square plus 2k into s plus 10 equal to 0, forming the Routh array s cube, first coefficient 1, leave the next, take the next 2k, leave the next, s square k plus 2, and here it is the 10, s power 1 k plus 2 into 2k, this will become 2k square plus 4k minus 1 into 10 minus 10 divided by k plus 2, this term will become 0, s power 0, this into this minus this into this, so again you will get what, 10. For systems to be stable, for system to be stable, the first common elements of the Routh array must be positive. Positive. It implies k plus 2 must be greater than 0. It implies k should be greater than minus 2. 2k square plus 4k minus 10 divided by k plus 2 should be greater than 0. In the sense, 2k square plus 4k minus 10 should be greater than 0. In the sense, what is the roots of the 2k square plus 4k? Roots of 2k square plus 4k minus 10 are 1.45 minus 3.5. In the sense, k should be greater than 1.45, k should be greater than minus 3.5. So total we have k should be greater than minus 2, greater than minus 3.5, greater than 1.45. K should be greater than minus 3.5. K should be greater than minus 3.5, and similarly k should be greater than minus 2, and k should be greater than 1.45. K should be greater than 1.45. 1.45. So the common area is K should be greater than 1.45. This is the stability condition. So answer for this question is answer D. So move to the next question. Bus impedance matrix for the network shown is in per unit impedance values are given. So we need to calculate the bus impedance matrix for a given network. Solution. So impedance matrix is a step-by-step process. We need to calculate the step-by-step process. So first, adding a reference bus, we are taking bus to the adding a bus 1 to the reference bus. Let's take this is the reference bus. We are adding a bus 1 to the reference bus with J.1. Step 1. Adding a bus 1 with reference bus having a branch impedance 0.1. So now the Z bus will become J.1. This is the 1 by 1 Z bus matrix. Now adding a new bus, step 2. Adding a new bus 2 to the old bus 1 with a branch having impedance J.2. Now this will become, this is the bus 1, this is the reference, this is the bus 2. Bus 1 already we have connected. Now we are connecting with the old bus 1 with a new bus 2 having a J.2, here J.1. Now the new Z matrix will become the old Z matrix J.1. The same thing will maintain J.1. The new will become the old impedance plus what is the bus impedance you are adding, J.2. So this is the new Z matrix. Now it will become 2 by 2 Z matrix. This is the 0.1 J.1. So J.1, this will become J.3. So this is the answer. J.1, 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 J.3 is the required answer. So answer for these things are option D. So answer is option D. Moving into the next question. So the change of order of integration, integral 0 to 1, integral y to 2 minus y, xy dx dy is. So we have to change order of integration problem. So now what they have given integral 0 to 1, integral 0 to 2 minus y, xy dx dy. We need to change the order of integration. Now the given integration is so integral 0 to 1, integral y to 2 minus y, xy dx dy. In the sense x is varying from y to 2 minus y and y limits are 0 and 1. In the sense, so x is varying from y. This is the one equation. Another equation for x is 2 minus y. The y limits are y equal to 0, y equal to 1. So this is the function, right? So if you see that and all, now x equal to y line is this one. This is what x equal to y line, and x equal to 2 minus y line. This is the x equal to 2 minus y line. So this is the y equal to 0 line. This is the y equal to 1 line. So this is the y equal to 0 line. This is the y equal to 1 line. So this is the x equal to y line. This is the x equal to 2 minus y line. Now we are integrating this using this strip, because this strip we are varying the x limits from y to the 2 minus y. We are varying the strip from y to the 2 minus y. This is the order of integration they have given. Now we need to change that order of integration. Rather than this, we need to change like this and all. This is the x-axis, this is the y-axis, this is the y equal to x, this is the y equal to 1, this is the x equal to y, this is the x equal to 2 minus y. Now rather than this, we need to change the order of integration. When you need to change the order of integration, now we need to split this area into two parts. Here we need to take one strip, here we need to take another strip. Now how to write this order of integration? By changing this. Now this new I will become, now look at, now again, now x limits are from, first case, x limits are from 0 to 1. X limit is fixed, 0 to 1. Now y limits are varying from, y is varying from this and this, right? This is a y equal to x to, this is what, y equal to 0. Now y limits are varying from y equal to 0, sorry, this is the y equal to 0. Y limits are varying from y equal to 0 to the y equal to x, y equal to 0 to the y equal to x, the function xy, so dy dx. This is for this region. For this region, now x is varying from 1 to 2, because this is a 0, this is a 1, this is a 2. Now x is varying from 1 to 2, and y varies from 0 to, now this line, so this is 2 minus x. Y is varying from 0 to 2 minus x, and xy dy dx. So this is the, we are changing the order of integration. Now it will become this and that. So answer for this question is, check it, 0 to 1, 0 to 1, 0 to x, xy dy dx, plus 0 to 2. Now 1 to 2, 0 to 2 minus x. So answer for this question is option D. So answer is option D. So answer is option D. Move to the next question. Seventh question. At the point x equal to 0.1, the solution of dy by dx equal to x square minus y of 0 equal to 1 using the Taylor series method is given by. By using the Taylor series method, initially at x equal to 0.1, we need to get the solution of this differential equation. So solution this is a numerical solution of a ordinary differential equation by using the Taylor series method. This is what numerical solution of ordinary differential equation by using a Taylor's series method. By using a Taylor series method. What is the Taylor series method says? So y equal to y naught plus x minus x naught into y dash of 0 plus x minus x naught whole square by 2 factorial into y double dash of 0 plus x minus x naught whole cube by 2 factorial into y triple dash of 0 and so on. This is the Taylor series. So given that this dy by dx is x square minus y. Dy by dx is x square minus y of 0 is equal to 1. X square minus y comma y of 0 equal to 1 and x naught is 0 here. Now what is the y dash? Y dash, when you differentiate this, y dash is x square minus y, right? It implies y dash of 0 is will become, when x equal to 0, what is the y dash value? When x equal to 0, y will become 1. So 0 square minus 1. 0 minus 1 will become minus 1. When x equal to 0, y value 1. Substitute equal to 0, y value 1, it will become minus 1. Similarly, what is the y double dash? So 2x, differentiate this with respect to x. 2x minus y dash. Again, y double dash of 0. Substitute x equal to 0. Now y dash become minus 1, substitute. It will become minus of minus 1. It will become plus 1. Similarly, y triple dash. Again differentiate this with respect to one more time with respect to x. Now it will become 2 minus y double dash. It implies y double dash of 0. Substitute y double dash equal to 1 in this. 2 minus 1 will become the 1. Similarly, y, again one more time with respect to x, if you differentiate, constant will become 0. This is a minus y triple dash. It implies y fourth of 0 will become minus 1. Now substitute all these values in this equation, that is y naught, because x naught equal to 0. In this equation x naught equal to 0, when you substitute, what you are going to get is y naught plus x into y dash of 0 plus x square by 2 factorial into y double dash of 0 plus x cube by 3 factorial into y triple dash of 0 plus x raised to 4 by 4 factorial into y 4 dash of 0. That's all, and so on. So when you substitute all these values in this, will become 1 minus x plus x square by 2 factorial means 2 plus x cube by 3 factorial means 6 into y triple dash is the 1, and if you substitute x raised to 4 and the y triple dash fourth dash of 0 is minus 1, so minus x raised to 4 by 4 factorial is 24. Now y we need at x equal to zero point 0.1, correct? Now substitute 0 point 0.1 plus 0 point 0.1 whole square by 2 plus 0 point 0.1 whole cube by 6 minus 0 point 0.1 whole raised to 4 by 24. Now when you substitute, it will become, this is the y of 0.1 will become 0.9051708. So 0.90517080. So answer for this is 905. Answer for this is D. So moving into the next question. Find the full scale output of a 4-bit ADC produces an output of 0.1 volt for a digital input of 0001. So DAC, digital to analog converter. So solution is the 4-bit means n equal to 4. The analog output voltage corresponding to the digital input. Analog output voltage corresponding to digital input voltage digital input voltage 0001 is equal to 0.1. It implies resolution is 0.1. Full scale output voltage. Now if you want to get a full scale output is full scale output voltage. Full scale output voltage is resolution in multiplied by maximum decimal. That will become full scale deflecting voltages. Resolution is the 0.1 multiplied by maximum decimal is 2 power n minus 1. So 0.1 multiplied by 2 power 4 minus 1. So this will become 1.5. So answer for this is option C. Moving into the next question. A system y of n equal to x of n minus x of n minus n is a non-causal, causal, either causal, non-causal, neither causal, non-causal. So answer for this question is it is a causal. Why? What is the definition of causal? The output of the causal system at the present time depends only on the present or past values of the input, not in the future values. Then we call it as a causal. In the sense, the output of the causal system at the present time depends only on present and or past values of input, but not on future values, its future values. Then such a systems is called causal systems. Now let's take the example, some n value positive, some n value negative. N equal to 1, it will become, so system y of n will become y of 1 at present nth sample is 1 equal to x of 1 minus x of 0. It depends present and past value of the input, so it is called. Similarly, when you take n equal to minus 1, y of minus 1 is equal x of minus 1 minus x of minus 2. Again, it is present and past, not in the future. So system is a causal. The answer for this question is option B. Moving into the next question. In spring control moving iron instrument, the scale is, it is cramped at the lower end and expanded at the upper end. Answer for this question is option C. Moving into the next question. What is the time required to deliver a charge of 200 ampere hour through a single phase off wave diode rectifier with an output current of 100 amps RMS and with a sinusoidal input voltage? So time required they are asking. So solution, let's see the solution for this solution. Given data, so I naught RMS they have given how much, 100 amps, and V naught RMS for this single phase off diode rectifier will become Vm by 2. It implies I naught RMS becomes Vm by 2R, that must be equal to 100 amps. In the sense, Vmax has to be becomes 200R. Now, for a single phase off wave diode rectifier, the average current will become Vmax divided by pi R. So substitute I naught equal to Vmax is 200R divided by pi R. That will become 200 by pi is the average current. Now what they are asking is required charge. What is the time required to deliver the charge of 200 ampere hour? So I naught is the time, is the 200 by pi into the time. So 200 but this is given as 200 ampere hours, 200 ampere hours. In the sense, time must be equal to pi, time must be equal to the pi hours. In the sense 5 is 3.14 hours. In the sense answer is for this is option A. Moving into the next question. In a CRO, the component used to amplify the signal amplified to the X plates is horizontal amplifier, trigger circuit, vertical amplifier, attenuator. So answer for this question is horizontal amplifier. Moving into the next question. So a 200-meter radial line AB with a resistance 0.2 ohm per kilometer go and return is, this 0.2 ohm per kilometer is including the return, is located with 100 amps at the end B and 100 amps at the midpoint C. If voltage at sending end A is 200 volt, then the voltage at midpoint C is. So distribution problem. So solution is, so there is a transmission or distribution problem. Sending end is point A, midpoint point C, receiving end is point B. At receiving end there is a load with 100 amps, and at midpoint another load with 100 amps. Sending end we have the voltage of 200 volt. 200 volt. Let's call this is the I1. Let's call this is the I2. I need the voltage at midpoint VC. Can I say voltage at midpoint VC is VA minus I2 into R2. This section having the resistance go and return is R2, right? So R2 total length is how much? 200 meter is 100 meter, and this is 100 meters. So 0.2 ohm per kilometer. In the sense, this having the resistance R1. So R2 will become 0.2 ohm per kilometer, right? 100 meters will become 0.1 kilometer into kilometer it have 0.2 ohm per kilometer. So R2 will become 0.1 into 0.2. This is the 0.02 ohms is the R2. Similarly, what is the I2 will become? I2 is the 100 plus 100. It is the 200 amps. Now the voltage drop VC will become is a 200 volt minus I2 200 amps into 0.02. So 200 minus 4, this is the 196 volt is the voltage at the midpoint C. So answer for this is option B. Moving into the next question. A long transmission line rated 100 MVA 400 kilovolt has the ABCD constant as below. A equal to D equal to 0.8 angle 5 degrees, B equal to 10 angle 40 degrees, C equal to 0.01 angle 90 degrees. If receiving end voltage at no load is 400 kilowatt, then the sending end voltage is. So solution. What is the transmission line equations? ABCD parameter equations. Sending end voltage A into VR plus B into IR. Similarly, sending end current is C into VR plus D into IR. They have given the data A equal to D equal to 0.8 angle 5 degrees, and they have given the B equal to 10 angle 40 degrees, and C they have given 0.001 angle 90 degrees. Now what we required at no load, at no load, it implies receiving end current is 0 amps. It implies when you substitute receiving IR is 0, now sending end voltage will become A times VR. Sending end voltage is equal to A is the 0.8 angle 5 into what is the given that receiving end is 400 kilovolt. So receiving end is 400 kilovolt. So substitute here 400 kilovolt. Now 0.8 times of 400 kilo is 220 angle 5 degrees kilovolt. So answer for this question is option B. Moving into the next question. In the circuit, they have given the circuit one dependent source, one independent source in resistance, and dependent source constant A is the to connect a resistance Rx in parallel with the voltage source and adjust it within the range of 0 to less than or equal to Rx less than or equal to 0.99 R such that voltage source delivers the minimum power. Find the value of Rx and the power delivered by the voltage source. So this is the problem. We need to calculate, we need to connect Rx parallel with the voltage source, and that Rx we need to vary from 0 to 0.99 R. In between we need to vary such that voltage source will deliver the minimum power to that. What is that value of R we need to calculate, and what is the minimum power supplied by the voltage source we need to calculate. So for this, first draw the circuit. Here it is, R is there. Next one dependent source is there. A is given 2, so this will become 2I1. Now we need to connect Rx parallel with the voltage source. This is the Rx parallel because all voltage source R, dependent source Rx, everything parallel. So we have to connect Rx, and this Rx range is point Rx is less than 0.99 R. 0 is less than or equal to Rx less than at 0.99 R. In this range we need to select Rx such that the voltage source has to supply a minimum power, and what is that power and what is this Rx value we need to calculate. They are saying that voltage source is delivering the power, in the sense the current in this direction must be in this fashion, then only voltage source will deliver the power. Is it right? Yes. Now you see here the this dependent source, this terminal is positive, this terminal is negative, because this dependent source is connected parallel with the voltage source. In the sense this dependent source is also delivering the power and independent source is also delivering the power. Both sources are delivering the power. Dependent source comma independent source, both are delivering the power. Both are delivering the power. To whom? Power to the R parallel with Rx. Correct? Total resistance in the circuit is R is parallel with the Rx. Now R V voltage source has to deliver the minimum power to this combination. Correct? That we call it as a R equivalent. Voltage source. What is the power delivered by the voltage source? Power delivered by the voltage source. This is the power delivered by voltage source. Power delivered by the voltage source to the R equivalent is or we can say voltage source is delivering the power as well as dependent source, both are delivering the power to the R equivalent. So power taken by the R equivalent, power consumed by the R equivalent is, because V is parallel with the this parallel combination, I can say P equal to V square divided by R equivalent. In this, some portion of the power is delivered by the independent source, some portion of the power is delivered by the dependent source. Now this power has to be minimum, means R equivalent has to be maximum in order to deliver in order to deliver minimum power to R equivalent. R equivalent must be maximum. In the sense, R equivalent is a parallel combination of Rx. So Rx parallel combination is R into Rx divided by R plus Rx. In order to get the R equivalent maximum Rx, you should select a maximum value. So in the sense, Rx we need to select 0.99 R. So one part of the question answer we got is as the variable resistance Rx to be selected 0.99 R in order to deliver the minimum power by the voltage source and current source. We got the Rx value. Now this R equivalent power must be power delivered by the voltage source, power delivered by the current source. So what is the power delivered by the voltage source? The power delivered by the voltage source is V square by power delivered by the voltage source is total power delivered to the R equivalent minus the power delivered by the current source. Power delivered by the current source will become power delivered by the current source is V into 2I1. Again, I1 is there, I1 is the current in this. So I1 I can write V divided by R. So power delivered by the voltage source is the total power consumed by R equivalent minus power delivered by the current source. Power delivered by the current source is V into 2I1. That is V square divided by R equivalent minus 2V into I1 is V divided by R. That is V square divided by R equivalent minus 2V square divided by R. Now what is the R equivalent? R equivalent is 0.99 R. Correct? So sorry, R equivalent, not Rx. Rx is 0.99 R. It implies R equivalent will become 0.99 R square divided by 1 plus 0.99 times R. This is 0.99 R square divided by 1.99 R. This is 0.99 by 1.99 R. Or I can say 99 by 199 R. This is the R equivalent. Now substitute. Now power delivered by the voltage source. This is the power delivered by voltage source. So V square divided by 99 R by 199. That means this will become 199 divided by 99 R minus 2 V square divided by R. So that V square divided by R, you can take it common, 199 divided by 99 minus 2. When you take the LCM, you are going to get V square divided by R, 199 minus 2 times 99 will become 198 divided by 99. So 199 minus 198 is 1 times, so V square divided by 99 R. This is the power delivered by the voltage source. V square divided by 99. So power delivered is V square divided by 99 R, and the Rx is 0.99 R. So answer is 0.99 R V square divided by 99 R. So answer for this is option B. Moving into the next question. A three-phase delta connected squirrel cage induction motor has a starting current of ID, delta connector motor starting current ID, and starting torque TD at rated voltage. If the starting current and starting torque while the motor is started through star delta and auto transformer with 60% voltage, stator alternatively are starting current of star connected star delta starter IY and corresponding starting torque TY, and auto transformer starting current I out and auto transformer starting torque is T out. Then what is the ratio of IY by ID, I out by ID is to TY by TD, T out by TC is equal to. So this question, now we'll see that DYL starter, DYL next and auto transformer starter, auto transformer. Now they have given that auto transformer starter turns ratio, or for auto turns ratio is 60%, 0.6, with the rated starting current and starting torque. With rated value, with rated values, starting current, here DVL starter is ID, starting current ID, and starting torque TD. Here in this case, D with the direct starting will become starting current with the DVL starter will become short circuit current. Yes, the starting torque will become same TD. they have given. So this is the star delta DYL starter. Now we have another star delta also. Here it is a star delta start and auto transformer start. In star delta starter, starting current will become ISC divided by root 3. In auto transformer, starting current will become X times the ISC. That means 0.6 times the ISC. Similarly, the starting torque with the star delta starter will becomes 1/3 of starting torque with the DOL. Here in auto transformer, starting torque will become X square times starting torque with the DOL. Here X is the 0.6, 0.6 whole square is 0.36 times TS DOL. Now what they are asking is current in with star delta start with the direct DOL start. Similarly, current with the auto trans with a direct DOL start. Starting torque with a star delta starter with a direct DOL start. Starting torque with the auto transformer with a direct DOL start. Now this will become, see, this divided by this will become 1 by root 3 is 2. Similarly, this divided by this will become 0.6. 0.6 is 2. This torque divided by this torque will become, sorry, this torque divided by this torque will become 1 by 3 is 2. This torque divided by this torque will become 0.36. Answer has to be 1 by root 3 is to 0.6 is to 1 by 3 is to 0.36. But if you see the given options and all, there is no proper matching option. We required 1 by root 3 is to 0.6 is to 1 by 3 is to 0.36. But there is no such a option available. So answer, no proper options given. So if they are not given marks to all, means you try to raise the objection against this question. So answer is this. This is the answer, actual answer. So move to the next question. What is the maximum output voltage of a three-phase bridge rectifier supplying with a line voltage of 440? So three-phase bridge rectifier, three-phase full bridge rectifier with R load for alpha less than or equal to 60 degrees continuous conduction. The output expression is 3 VML by pi into cos alpha. So the maximum voltage is 3 VML by pi. 3 VML by pi. So 3 by pi into maximum line value, in the sense root 2 times RMS value of the line voltage. So 3 by 5 into root 2 into 440 is the line voltage. We substitute, this is the 594.8 2 volt. This is the answer. 594. So answer for this is option D. Moving into the next question. A super circuit is operating on time ratio control mode at a frequency of 2 kHz of a 230 volts DC supply. For output voltage of 170 volts, the conduction and blocking period of a thyristor in each cycle are respectively is given. Super circuit operating in a time ratio control mode. Frequency of switching is 2 kHz and DC voltage input voltage 230 volts. We require the output voltage of 170 volt. Further, what is the conduction time period and blocking time period of a thyristor? They are asking. So, solution. So, given data is a super switching frequency 2 kHz. Next, voltage source is 2 230 volt. Now, average output is del times the Vs. From this, del is V0 by Vs. We required V0 is the 170. They given output voltage is the 170 volt, and Vs is the 230 volt. So it becomes the del is 0.739. So on time is del times the T, that is, this is the 1 by T, that is the F. Now will become, on time will become 0.739 divided by T is 1 by F 2000. So T on will become 3.695 into 10 power minus 4 or 0.365 milliseconds. 0.365 milliseconds. This is the on time. And similarly, what is the off time? T off is 1 minus del times the T. 1 minus 0.739 divided by 2000. So T off time will become 0.1305 milliseconds, or you can say 0.131 milliseconds. From this, 0.131 seconds. Answer for this is option A. Answer for this question is option A. Moving into the next question. Electrical resonance type frequency meter working is dependent on electrical resonance. Answer for this question is option B. Electrical resonance. Moving into the next question. An electric motor develops a starting torque of 50 Newton meter, starts with a load torque of 7 Newton meter on its shaft. If acceleration at a start is 2 radians per second, the moment of inertia of the system must be neglect viscous and Coulomb friction. So solution for this is yes. So electrical torque is given 15 Newton meter and load torque is 7 Newton meter. And also they are giving acceleration 2 radians per second square. And they are asking to calculate the moment of inertia. So the torque is accelerating torque, electrical torque minus load torque. 15 minus 7, 8 Newton meter. Now accelerating torque is J times moment of inertia J times d square del by dt square. This is the acceleration. Other terms they are asking neglect viscous and Coulomb friction. So other terms are neglected. They itself they are asking. That is J times A. From this moment of inertia is accelerating torque by A. Accelerating torque 8 divided by acceleration is 2 radians per second. Now it will become 4 kg meter square. So J is the 4 kg meter square is the answer. So answer for this is option D. Moving into the next question. A three-phase synchronous motor connected to an infinite bus is operating with a nominal excitation. With the decreasing in load, armature current V decreases, power factor becomes lagging, power factor becomes leading, load angle decreases, reactive power flow from motor to bus, reactive power flow from bus to motor. From the above statements, which of them are correct? The given A, B, C, D, F, in that which statements are correct they are asking. For this, they have mentioned synchronous motor, correct? So synchronous motor now operating connected to infinite is operating at a nominal excitation. Now we will see that synchronous motor operating at a nominal excitation. This is the V at nominal excitation. This is the I. So this is the IAXS. When you add V plus IAXS, neglecting the resistance, now this will become the induced EMF E for the synchronous motor, and this will become the del, and this is the load. This will become the load. Now synchronous motor connected to infinite bus, right? So power is EV by X sin del. When connected to infinite bus, V remains, and also this will become VIA cos phi. When system is connected to infinite bus, V becomes constant, and XS as synchronous reactance becomes constant. V and XS, this is the X, V, X are constant. I can say that the power is proportional to E sin del. Real power is proportional to the E sin del. Similarly, real power is proportional to IA cos phi. And what about the Q is proportional to I sin phi? Now this is the initial operation of the synchronous motor operating at nominal excitation. Now real power is proportional to E sin del. So this axis will represent what? This axis will give the real power, because this is the E, this is the del. E sin del is the vertical line. That vertical line will give the real power. Similarly, Q is proportional to I sin phi. Reactive power will becomes this horizontal line. This is the normal excitation. Now this will become the MVA, or reactive or leading, or we can say that it is the export or deliver. If you come to the reactive power in this direction, this will be the MVA or lag or import. Now what they are saying is, with decreasing in load, now load has decreased. This is the vertical line represents the load. Now load has decreased. Now excitation you are not changing. When excitation you are not changing, E you need to maintain the constant. When excitation not changing, we need to maintain what? This is the locus of E. Now this is a new operating point, because now you have decreasing the load. Now in this case, this will become the new E, and this will become new IAXS. This is the E1, this is the IA1 XS, and perpendicular to this, somewhere it will become I. This is the I1. Now XS is constant. Here IA XS, this length is the IA1 XS, this length is the IA XS. XS remains the same. If you observe that this length is less than this length, in the sense IA1 is less than IA. IA1 less than IA means when you decrease the load, armature current is decreasing. Correct? When you decrease the load, armature current is decreasing. In the sense, option A seems to be correct. Now this is the power factor angle phi. Now it is becoming the leading. This is the corresponding var. It is exporting. And what about the del? This is the del 1. Del 1 decreases. Now you see that power factor becomes lagging, but now reactive MVA var lead. So option B is the wrong. What about the option C? Power factor become leading. Correct. What if option D? Load angle decreases, means del. Now del 1 is less than del. Load angle is decreasing. So option D is the correct. What about the option E? Reactive power flow from the motor to the bus. MVR lead, and leading operation of the synchronous motor, it will export or deliver, means motor delivers the reactive power to the, so reactive power flow from motor to the bus, motor delivered the reactive power to the bus. So option elective. So this is the E is the correct. Reactive power flow from bus to the motor. Option F is the wrong. So correct answers is A, comma C, comma D, comma E. This is the correct answer. But options what they given, C, D, E is given. A is missing. From the above statement, which of them are correct? Above A also correct, but they have not given that A. So strictly speaking, they have to give A also. So they have not framed the answers properly. So you can raise objection against this if they are not giving the marks means. So answer for this is this. So actual answer is A, C, D, E. So moving into the next question. So in the reason r less than or equal to 2, electric displacement density or electric flux density D equal to 5r square by 4 in the unit vector in the radial direction, and for r greater than 2, displacement flux density D equal 20 by r square in the r in a spherical coordinates. Find the charge density for r greater than 2. Now what they have given displacement flux density 5r square by 4 the unit vector for r less than or equal to 2. Similarly, D equal to 20 by r square r cap for r greater than or equal to 2. We need to calculate charge density for r greater than 2. In the sense, we need to use this value. So generally D means this have the components in a cylindrical coordinates. This has components dr into r cap plus d theta into theta cap plus d phi into phi cap. By comparing this both case, the d theta is 0 comma d phi is 0. For r greater than 2, so dr is 20 divided by r square. Now charge density is rho equal to del dot d, divergence of d. For a cylindrical coordinates, for a cylindrical coordinates, del dot d we can write as 1 divided by r square sine theta of dou by dou r of d suffix r into r square sine theta plus dou by dou theta of d suffix theta into r into sine theta plus dou by dou phi of d suffix phi into r. But d phi is 0, d theta is 0. We need charge density. This is the charge density for r greater than 2. For r greater than 2 meters, the charge density rho is del dot d is 1 by r square sine theta into dou by dou r into what is the dr for r greater than 2? 20 by r square. So 20 by r square into sine theta plus this is entire term becomes 0, d theta is 0, this term is 0, d phi is 0, so 0 plus 0, this r square get cancelled, dou by dou r of 20 into sin theta will become 0, so charge density will become 0. So answer for this is option C. Moving into the next question. The open loop transfer function of a Bode magnitude plot is given. They're asking to identify the open loop transfer function of a given Bode plot. So how to get this is by observing the initial slope. It is a 40 dB per decade. Initial, there is a straight line means there is no poles or zeros at origin. Initial slope is negative means there is a poles at origin. Initial slope is positive means there is a pole at, there is a 0 at origin. Now it is a 40 means each 0 will contribute plus 20 dB per decade. That means there is a 2 zeros at origin will be there. So the g of s, so g of s, h of s must have some gain constant k into 2 zeros at origin, because initial slope will give the idea how many poles or zeros at origin. So ks square. The next corner frequency is the 5. Now slope initially 40 now becomes the 20, decreased in the sense a pole is added, pole contribute to the minus 20 dB per decade. Initially 40 minus 20 now becomes the 20, in the sense a pole at 5 radians means s plus 5. The again corner frequency is the 50. At 50 now slope becomes 0 means again minus 20 is added to the 20, in the sense again a pole with a corner frequency 50, s plus 50. So k into s square by s plus 5 into s plus 50. So answer for this is option B. So moving into the next question. A single phase line 230 volt, three phase line 400 volts, which fed a different domestic circuits and industrial loads requirements. See, mixing of single phase and three phase will available only at secondary distribution side. So answer for this is option D. Moving into the next question. A 200 volt, 220 volt, 50 Hz transformer with a 0.35 mm thick lamination has eddy current losses of 120 watts, which is a 2/3 of the total losses at no load. At no load, total losses is the iron loss. So eddy current losses is the 2/3 of the iron loss, and that equal to 120 watts. And if the transformer is built with a 0.7 mm thick, now lamination thickness they have changed, build with a thickness, and it worked from 110 volt 25 hertz. Now voltage become off, frequency also become off, keeping V by F is a constant. Then the total no load loss would be, we need to calculate the total no load loss. So solution, now the case 1 what they are giving is thickness is given 0.35 mm, case 1, and also frequency given 50 Hz, next voltage is given 220 volt, and the eddy current loss in the first case represented by suffix 1 is 120 watts, that is a two-third of the total iron loss in this case 1. This is the data given. In case 2, they have said thickness is now changed to 0.7 mm and the voltage will become 110 volt, frequency will become 25 Hz. Now if you see that V by F ratio, V1 by F1 is 220 by 50. Similarly, that is a V2 by F2 is 110 by 25. From this, V1 by F1 equal to V2 by F2 is equal to constant. That is proportional to Bmax. V by F is proportional to the Bmax. Now, here from this I can write a iron loss in this case is 3 by 2 times of 120 watts. So iron loss in this case is 180 watts. If iron loss is 180 watts, what is the hysteresis loss in this case? Hysteresis loss is 180 minus 120, 60 watts. Now coming to the what is the hysteresis loss? Hysteresis loss is some constant, hysteresis constant, F times B max power 1.6 times the volume. In this case volume is constant, no, volume can be treated as constant. From this I can say VH2 by VH1, constants will get cancels. Now F2 by F1 whole power 1.6, sorry, F2 by F1. Anyhow, Bmax is a constant. From this pH2 by pH1, pH2 is F2 by F1 times pH1. Substitute 25 by 50 times pH1 is 60. This becomes 30 watts. Similarly, eddy current loss is some eddy current loss coefficient Ka F square times Bmax square into T square into volume. In this case volume is constant, so eddy current loss 2 by eddy current loss 1 is F2 by F1 into T2 by T1 whole square. Remaining all are constants. Now when you substitute, F2 is 25 by F1 is 50, T2 is 0.7 divided by 0.35 whole square. Now it will become 1 E2 by eddy current loss 1. Now PE2 becomes PE1. PE1 is how much? This is a 120 watts. Now total iron loss in the second case is PH2 plus PE2. PH2 30 plus PE2 120. So 150 watts. So answer for this is option C. Moving into the next, a 50 Hz 4-pole turbo alternator rated at 20 MVA 13.2 kV has an inertia constant H is equal to 4 kW per kV. The kinetic energy stored in the rotor is, so kinetic energy formula is motor rating into inertia constant. The given motor rating 20 MVA they have given and inertia constant 4 kW per kVA they have given. So kinetic energy will become 20 into 4 becomes 20 into 4, that will become 80, 20 kilo 20 MVA into kilowatt for kW. So 80 megajoule. So answer is D. Next, moving into the next question. Summation of signal n equal to minus infinity to infinity del into n minus 2 sin 2n is solution, because summation of n equal to minus infinity to infinity del of n minus 2 into sin 2n equal to, because sin 2n signal is multiplied by the impulse sampled at 2, this will become summation n equal to, sorry, so simply nothing but substitute sin 2n n equal to 2, it will become sin of 2 into 2 sin 4. So answer for this is option B. Moving into the next, steady state stability of a power system can be increased by connecting lines in series using emission of high impedance, reducing efficiency of matrix missions, reducing the excitation of the missions, connecting lines in parallel. So answer is connecting lines in a parallel. So answer D. Moving into the next question, the absolute maxima and minimum value of f of x equal to x power 2 by 3 on the interval minus 2 comma 3 are, we need to calculate absolute maxima and minima. Now the given function is solution, the given function is x power 2 by 3 in the interval minus 2 comma 3, right? You substitute f of minus 2 cube root of 4, that is 1.587. If you substitute f of 3 cube root of 9, 2.08. If you substitute f of 0, this will become 0. So 1.587 to 0, it is decreasing in this, it is decreasing function, and 0 to 3, so 0 to 2.08, it is increasing. The nature of this function is in the interval minus 2 to 0, it is decreasing, from 0 to 3, it is increasing. Means at 0 it has a local minimum, that is f of x is a decreasing function in the interval interval minus 2 comma 0, and increasing function in the interval 0 comma 3. So it has a one local minimum, so it has one local minimum at x equal to 0, and the local minimum value, and the local minimum value is equal to x of minimum value equal to f of 0 is 0. Now absolute maxima or minima. What is the definition of absolute maxima and minima? If f of x is defined, if f of x is defined in the interval a comma b, then absolute minimum value is equal to minimum of f of a, f of b, all local minimum values, comma, all local minimum values. Now for the given function we have calculated f of a and f of b. This is the a, here a equal to minus 2, b equal to 3. So f of a is the 1.587, f of b is 2.08, but in between there is a one minimum at 0, that value is 0. So local minimum value is 0, and f of a is 1.587, f of b is 2.08. So minimum of f of a is the 1.587, f of b is the 2.08, and local minimum 0. So minimum of all these things are 0. So absolute minimum value is 0. Now similarly, what is the absolute maximum? Now absolute maximum is equal to maximum of f of a comma f of b comma all local maximum value, all local maximum value. So we don't have any local maximum values, so we need to take maximum of f of a is the 1.507 and f of b 2.08. Absolute maximum value is 2.08, that is cube root of 9. So absolute maxima and minimum values will become absolute maximum and minimum values. This will become cube root of 9 comma 0. So from this, what is the answer? Answer for this question is answer D. Option D is the answer. Moving into the next question. Moving into the next question, 30 question. They have given the network with impedances like 6 ohms, so capacitance 4 Henry, capacitances V1 V2. In the circuit V1 and V2 are AC voltages excited with V1 is 6 cos omega t, V2 cos omega t plus 6. Find VA. We need node voltage VA if omega equal 2 radians per second. 2 radians per second. Now solution. Solution. Given data V1 equal, I am writing the phasor notations. V1 is 6 angle 0, V2 is the 1 angle 60. 6 angle 0, V2 is the 1 angle 60 degrees, and omega is the 2 radians per second. So nodal analysis, by applying the nodal analysis we are in a position to find out the node voltage gain. Now the given circuit will become, this is the V1, inductance will become J 6 Henries, so omega L 6 into 2 12 Henry. Similarly farad 0.5 1 by omega C, 1 by 0.5 into 2, 1 by 1 is the 1, 1 by 1 into 2, 1 by 2 is the 0.5. So J12, so J1 J1 minus J 0.5 J 0.8 V2. This is the I2. Let's assume this is I1. This is the node voltage at node A. This is the reference we have taken. Now applying the nodal voltage at node A, we can write as VA minus V1 divided by J12 plus VA divided by impedance of this branch, so J8 minus J.5 plus VA minus V2 divided by minus J equal to 0. When you rearrange these things, VA minus 6 by J12 plus VA divided by J7.5 plus VA minus 1 angle 60 divided by J equal to 0. Now VA minus 6 by 12 plus VA by 7.5 minus VA plus 1 angle 60 equal to 0. So this all we are multiplied with a J. Now we are taking the LCM and rearranging. Now it will become 7.5 times VA minus 6 plus 12 times VA minus 90 VA minus 90 VA plus 90 into angle 60 equal to 0. Now 70.5 VA equal to 90 angle 60 minus 45 angle 0. That will become 77.94 I. So VA is 1.1056 I. So or we can say that when you approximate, this will become 1.11 angle 90 degrees. If you write in terms of that, come to 1 minute. See, this is 90 60 minus 45. This from this step, how you got the directly means, so I use the calci. If you want to do in the examination, the other way you can do it is, see, look at 70.5 VA equal to 90 angle theta 60 degrees cos 60 minus plus j sin 60 you have to write. So 90 into cos 60 plus I into 90 into sin 60, again minus 45 degrees angle 0. From this 70.5 VA equal to 45 plus I into 77.94 minus 45. So 70.5 VA is will become the I into 77.94. From this VA will become the 77.94 divided by 70.5 into I. VA will become the 1.11 I or 1.11 angle 90 degrees. That is what we have. So in this case 1.11 VA cos of omega t plus 90. Omega is given 2, correct? So VA has to give 1.11 cos 2t plus 90 degrees. This is r cos 90 plus theta minus sin theta minus 1.11 sin 2t has to give, or the same thing we can write as 1.11 sin 180 plus 2t. Third quadrant sign negative. So all these are the correct answers. All these are the, sorry, so 1.11 cos 2t plus 90 or minus 1.11 sin 2t or 1.1 sin 2t plus 180. But if you see the answers given in this, they have missed the minus 1.11 sin 2t. Correct, or either it has to give minus 1.1 sin 2t or 1.11 sin 2t plus 180. So correct answer not matching. So not matching with given options. Given options. If you want, you can raise the objection against this question if they are not giving marks to everyone. So we'll move to the next. Yeah, still there is a 10 questions remaining. We'll take some small break. After that, in the next session, we will continue the remaining solutions. Thank you. We'll continue the rest of solutions in this session itself. The next question is question number 31. The phase lead network has its transfer function GC of S is 1 plus 0.04s by 1 plus 0.01s. What is the frequency at which the maximum phase lead occurs? It's a direct formula. So phase lead network, solution. The maximum phase lead occurs at sine inverse A minus 1 by A plus 1. What is the phase lead network transfer function? Lead network transfer function will become, the transfer function will become, G of S will become 1 plus ATS divided by 1 plus TS. Compare this transfer function with this and try to calculate A and T. By comparing these things and all, AT is 0.04 and T is 0.01. It implies A is 4. A is equal to AT by T. 0.04 by 0.01. It is the 4. So maximum phase lead. What is the maximum phase lead? The maximum phase lead is phi m. Phi m is sine inverse of 4 minus 1 divided by plus 1. Sine inverse 3 by 5. Sorry. 3 divided by 5. So sine inverse of 3 divided by 5. Something answer is missing. Phase-late network has a transfer function 1 plus 0.04. AT is T is the 0.01. So A equal to AT by T, 0.04, 0.4. 4 minus 1, 3 divided by 4 plus 1, 5. 3 divided by 5. Shift sine inverse answer. 36, 25, 50, 74. For max is sine inverse 3 by 5 is 36.87 degrees. But maximum phase lead occurs. This is the maximum phase lead. But at what frequency? Omega m is the geometric mean of two corner frequencies. So omega m, and we need to calculate the maximum occurs at a frequency omega m. So what is the two corner frequencies? This is the corner frequencies under root 0.04 into 0.01 under root answer divided by answer is 50. Yes. So corner frequencies omega n is 1 by 0.04 and the other corner frequency is 1 divided by 1 plus 0.01. So substituting these values, so the maximum phase lead occurs at a frequency omega m is equal to under root of 1 divided by 0.04 into 0.01. Now this will become 50 radians per second. So answer for this is option B. Moving into the next question. In the region 0 is less than or is less than 0.5 m, the cylindrical coordinates, the current density is, for cylindrical coordinates, when radius is less than 0.5 meters, current density is 4.5 into e power minus 2r into Aj ampere per meter square. And elsewhere it is the zero current density. Use Ampere's law and find the magnetic field intensity H. So the given options are this. Solution for this problem is So they have given the data. Given data is current density J is 4.5 into e power minus 2r into unit vector in the z direction. It's ampere per meter square. For 0 is less than or is less than 0.5 meters. Otherwise it is 0 elsewhere. It is 0 elsewhere. That is for r greater than 0.5 meters. This is the given data. Now to apply the Ampere law, we need to choose the Ampere path, right? So the current density is symmetric around the z axis. The current density is symmetric around the z axis. A circular path on the constant. A circular path on the constant z plane is chosen as the Ampere path. That is this is the cylinder. This is the z axis. This is the z axis. This is the radius. This is the theta. So the current density is symmetric around the z axis. So around the z axis, current density is symmetric, a circular path on the constant z plane. In the sense, whatever you have seen this dashed line, that is the plane where in this plane only we need to choose the Ampere circuit path. Now for radius less than 0.5 meters, by applying the Ampere circuit law, the closed loop of H dot dl will become current density covered by that surface ds. Now for r less than 0.5, this is the uniform current density, so H dot dl you can write as H into 2 pi r equal to integral of j dot ds. Now ds is the surface we have chosen, which is as dotted in this. So this is the surface is with respect to the r and theta. So r and sorry 5. So 5 varies from 0 to 25. R varies from 0 to R. So for R less than 0.5, J is this value. J value is 4.5 e power minus 2R into AZ dot. What is the ds value? Ds value is R into dr into d5 Z. So this is the ds component. Okay. So from this, h into 2 pi r equal to, I can separate out this. Phi is 0 to 25 into d5 and 4.5, you can bring it a constant front. The remaining thing is r is 0 to r into e power minus 2r into dr, r into e power minus 2r into dr. Now h into 2 pi r is equal to 4.5 into 5 varies from 0 to 2 pi, and this integration separately will do, that is r equal to 0 to r into e power minus 2r into dr. This integration we have to do by integration by the parts and all. Yes. This integration we need to do by using the integration by the parts. So first we will calculate this integration and we will come back to this. So this integration by parts, what is the formula for the integration by the parts? By parts, what is the formula? Integral uv dx is equal to u into integral v dx minus integral of derivative of u into integral v into dx into dx. This is the formula. Now for this given function I am taking the u as r and v as e power minus 2r. Now this will become r equal to 0 to r e power minus 2r dr will become u is the r integral v e power minus 2r into, we are integrating parts with respect to the r, dr minus integration of derivative of u, derivative of r with respect to r will become 1, integration of e power minus 2r dr into dr. this entire whole thing we have to apply the limits r equal to 0 to r. Now when you substitute this, and what you are going to get is what? E power minus 2r integration will become e power minus 2r by minus 2. So r into e power minus 2r by minus 2. The second one will become, this minus of minus plus will become, so e power minus 2r by 1 by 2 into dr. So entire thing is limits r equal to 0 to r. Now this integration by parts will become, when you substitute these things and all, minus r e power minus 2r by 2, again this integration will become minus 1 by 4 and e power minus 2r divided by 4. In this, limits r of r equal to 0 to r. When you substitute 0 to r, it will become minus r e power minus 2r by 2 minus e power minus 2r by 4. This is the upper limit, minus of lower limit. When you substitute minus of lower limit, it will become 0. This will become minus 1 by 4. Minus of minus 1 by 4 will become plus 1 by 4. So when you take the 4 taken out to be the common, this will become 1 minus e power minus 2r minus 2r into e power minus 2r divided by 4. This is the integration by parts. For this integration we got the values. Now here, that is the integration by parts, we need to substitute r equal to 0 to r e power minus 2r into dr. Now this will become h into 2 pi r into 4.5 into 2 pi into 1 by 4 into 1 minus e power minus 2r minus 2r into e power minus 2r. So h into 2 pi r is 4, when you get cancels, 1.125 into 2 pi into 1 minus e power minus 2r minus 2r into e power minus 2r. Now from this, what you are going to get is h will become, this 2 pi will get cancels, 1.125 divided by r into 1 minus e power minus 2r minus 2r into e power minus 2r. If you write in terms of the vector, h will become 1.125 divided by r, 1 minus e power minus 2r minus 2r into e power minus 2r into unit vector along with the direction 5. So this is the answer. Units for ampere per meter for the range of 0 is less than or is less than 0.5 meters. Question: use ampere circuit, find the H. They said find the magnetic field intensity H, but they didn't say that in which region, whether it is in this region or for r greater than zero point 0.5 meters region. They have not mentioned clearly. Correct? So answer for this meters in the cylindrical rates. In the region, in the cylindrical coordinates, the current density is and 0 elsewhere. Use amperes, find H. H where we need to calculate, they have not clearly mentioned. If you calculate the H for this reason, answer is coming out 1.125 by R into 1 minus e power minus 2R into e power minus 2R coming. This is the answer is coming, right? Answer A is coming. Suppose if you want to calculate the magnetic field intensity for R greater than 0.5 means that also we can calculate for R greater than 0.5 meters. Now the enclosed current will becomes only, in this case the enclosed current will become 1.125 into 2 pi into 1 minus e power minus 2r minus 2r e power minus 2r, where r will become 0.5 meters. Substituting that enclosing current, the current will become, when you substitute r equal to 0.5, it will become 1.125 into 2 pi into 1 minus e power minus 1 minus 2 into 0.5, 1 into e power minus 1. So current enclosed will become 0.594 pi. Now, according to the Ampere circuit law, closed integral of h dot dl equal to total current enclosed j dot ds, that is nothing but current enclosed. In previous case also, when you use the Ampere circuit law, this itself the current enclosed, that is the total current enclosed. Moving into the next, total current enclosed, then substituting, now closed integral h dot dl, we got 0.594 pi. From this, h into 2 pi r is equal to 0.594 pi. From this, h is equal to 0.594 pi divided by 2 pi r, or you can say that h is equal to 0.297 divided by r. In terms of the vector, 0.297 divided by r into unit vector along with phi direction. This is the ampere per meter. This is the magnetic field intensity, ampere per meter for r greater than 0.5 meters. So answer for this question can be possible two answers. One is for r less than 0.5 meters, r less than 0.5 meters, this is the answer. For r greater than 0.5 meters, this is the answer. So question clarity is missing. They should have mentioned use Ampere's circuit law and find the h For r less than 0.5 they should have mentioned r, for r greater than 0.5 they should have mentioned. If r less than 0.5 means answer A, if r greater than 0.5 means there is no answer, the answer is this one. So you decide if you want to object this question, you can raise the objection also. So moving into the next question. The Fourier transform of f of x equal to 1 for mod x less than or equal to 1, 0 mod x greater than 1. The Fourier transform of, this is a rectangle signal, we need to calculate the Fourier transform. Solution. Given signal is the rectangle signal. X f of x amplitude 1 for ranging -1 to 1. This is the meaning, mod x less than or equal to 1 means this signal exists from -1 to 1 with amplitude 1. Elsewhere it is the 0. This is the rectangle signal representation. Now Fourier transform of this signal we need to get is. So the definition of the Fourier transform is f of s equal to 1 by under root 2 pi integration minus infinity to infinity f of t e power jst into dt. Now 1 by under root 2 pi integral, but signal existing from -1 to 1. So rather than minus infinity, infinity minus 1. And f of t, the signal magnitude is only 1 into e power jst into dt. So now this will become 1 by 2 root pi into e power jst will become e power jst divided by js, and substituting the limits from -1 to 1. So when you substitute, this will become 1 by root pi into 1 by s into, it will become what, e power jst minus e power minus jst by I is there. I can write here numerator 2, here 2, so that this will become what, sin s, sorry, e power jst will become, when you substitute t equal to 1 and -1, this will become minus js plus js. T in t sub place we are substituting 1 and -1, so this will become this. So this is the sin s formula. So substituting this, that will become, so root 2 times under root 2 by pi into 1 by s into this is will become sin s. So under root 2 by pi sin s by s, under root 2 by 5 sin s by s. So answer for this is, answer for this problem is option A. Moving into the next question. Yeah. See, this is a very big question. So wantonly they are giving these problems to trap you, to waste our time and otherwise it will take minimum 4 to 5 minutes and see, consider the unit value as the reference and match the approximate values of the armature current and the speed in the column 2 with respect to the column 1. Select the correct answers in the code given below. They are saying that a terminal voltage have offered field current and the load torque constant keeping. This is the case 1. So column 2 they have given the armature current. This is the armature current and this is the speed and all. If you do like this and all, what will become the armature current, what will become the speed and all, like that they are asking. Now look at, let's take the separately excited. So DC machine, DC motor will take DC motor. Now torque equal to K5 Ia and induced EMF equal to K5 omega. Now column 2. This is the armature current. This is the speed. And now this is the column 1. We will see that what is the condition of in case the first case we will take the case A. Case 1, case 2, case 3, case 4. Now we will take the first case. Terminal voltage held, terminal voltage halved, field current and load torque becomes constant. What is this case? Terminal voltage halved. So separately excited, right? So we will take it as separately excited. So IF will become constant. So armature terminal voltage will become off. So because they mentioned the field current and load torque are constant. So IF is a constant. So terminal voltage will become off. Terminal voltage means V2 will become off of the V1, comma load torque is a constant, right? Okay, load torque will become constant. So torque is K phi Ia. When torque is constant, phi is also, because phi is proportional to IF. If IF is constant, phi constant. Phi constant, if torque constant means Ia has to be constant, right? It implies Ia has to be constant. So what about the speed? Speed is proportional to induced EMF. When you neglect the losses, E is approximately equal to V. Then in this case, E2 will become half of the E1. It implies phi is constant, E is proportional to the speed, E is proportional to the speed. So E2 will become half of, so E2 will become, E is proportional to the speed. Now N2 will become half of, N2 will become half of N. In the sense, Ia will becomes same, constant means 1 per unit. Speed will become 0.5 per unit. This is the case 1. So for this Ia has to be 1 and speed has to become 0.5. 1 and 0.5 is matching here. In the sense, A has to match with the option 2. Coming to the second option B. In B, what they are saying, terminal voltage halved, field current and power output is constant. So terminal voltage, field current is constant, IF is constant, right? Power output is also a constant, but terminal voltage will become off. This is what the given conditions. So when you neglect the losses, when terminal voltage, when neglect the losses, I can say P in is almost P out. When terminal voltage will become half, what is the input current will become? 5. Now I2 will become 2 times the I1. Is it right? I2 will become 2 times I1 means this current will become 2 per unit. What about the speed? Speed is proportional to the induced EMF. When induced EMF will become half, then when you neglect the loss, voltage drop is approximately V. When V is becomes half, E2 will become half of the E1. It implies N2 will become 0.5 times the N1. So 2 and 0.5, this is the 3. Option 3 is the matching. Next, coming to the third portion, come to here, third portion. Again this column and 2, this is the current and this is the speed. Now in this third case, what the field flux doubled, phi becomes 2 times the phi 1. Okay, and armature voltage halved and power, so okay, armature voltage halved and the power output constant. P output is the constant. Next, armature voltage halved, flux becomes 2 times. Okay, armature voltage and load torque is constant. Sorry, field flux doubled, armature voltage and load torque is constant. This is the fourth we went. Sorry, we are discussing now the third. We'll see that field flux is doubled, armature voltage and load torque is a constant. That means V is the constant, T is the armature voltage and load torque is the constant. Now torque is K phi Ia. Phi becomes 2 phi. Torque has to be constant means I has to become off. Correct? So torque is K phi Ia has to be constant, but phi becomes twice. I has to becomes off. Then only it will become constant. 2 phi. Then I has to become off. Then only it will become constant. In the sense, I has to be 0.5. What about the speed? Speed is K phi omega. So this is a constant. Phi becomes the twice because then speed has to becomes again off. So in this case speed has to becomes off. So both 0.5 0.5, it is the option 1. Now the last flux, field flux half, that is phi becomes 0.55, phi 2 becomes, and voltage half, power output is constant. So V2 becomes half of the V1 and power output is the constant. Now in this case P output is constant, P out equal to Pn, that is equal to V1 by 2, voltage becomes off, then current has to become 2 times I1, that means current has become twice, 2.0. Now what about the speed? Speed is K phi omega m. Phi becomes, so speed, the voltage will become off, E is K phi omega m, E2 phi to omega 2, E2 is V1 by 2, K phi 2 is phi 1 by 2, so omega m2, so 2 get cancels, so omega 2 becomes a constant, omega 2 will not change it. That means speed n2 will become n1, so this will become 1.0. So 2 and 1.0, this is the fourth option. So the correct matching option is A is the 2, B is the 3, C is the 4 and D is the, sorry, C is the 1 and D is the 4. 2 3 1 4, 2 3 1 and 4, answer C is the correct option. Answer is C is the correct answer for this question. Moving into the next question, control system. The transfer function of the block diagram is, we need to calculate the transfer function. Answer, solution. So by using the Manson's gain formula, how to write the transfer functions? Summation k ranging from 1 to n pk del k by del, where k is the variable, sorry, pk del k by del, where n is the number of forward paths, pk is the forward path gain, del k is the determinant of the graph which is not touching the kth forward path, d is the determinant of the whole graph. Now you see how many forward path will be there. This is the one forward path, the other forward path is this. There is only two forward paths. How many loops will be there? There is this one loop and this one more loop. There is a this one loop, then this another loop. There is a two loops will be there. So by using this, the transfer function is, the first forward path gain is 4 by s into 1 by s, 4 by s square into 1 s square into graph of the determinant which is not touching this forward path is nothing, so only 1, because 1 minus sum of the individual loop gains, there is no loops forming at all. Similarly the second forward path will be 2 into 1 by s, 2 by s into, without touching this also there is no individual loops at all. In the sense, the determinant of the graph for this corresponding to this forward path will be 1. So 4 by s square into 1 plus 2 by s into 1 divided by total determinant of the graph is 1 minus sum of the individual loop gains. There is a two loops. This loop is 4 by s into 1, 4 by s square minus 4 by s square is the one loop gain. The other loop is minus 2 by s is the other loop gain. So there is no non-touching loops and all, only two independent loops are is there. By simplifying these things and all, you are going to get 4 plus 2s by s square divided by s square plus 2s plus 4 divided by s square. So s square get cancelled. 4 plus 2s divided by s square plus 2s plus 4. 2s plus 4 by s 2s plus 4. Answer is B. Answer for this question is B. Next, moving to the next question. A lightning arrestor connecting the line and earth in a power system is reflect back the traveling wave approaching it, protects the terminal against the traveling circuit, protects the transmitter against the direct light stoking, no, suppress the high frequency in the no. The answer is B. Answer for this question is option B. Moving into the next question. In 8085, the number 45 hexa and 72 hexa are added. The resulting clock settings will be as follows. So when you add the 45 hexa and 70 hexa, now when you do it addition and all, what you are going to get is carry flag resets, auxiliary carry flag sets. So answer for this is B. You do the addition of this hexa number of 45 and 70, you come to know that carry flag is going to reset and auxiliary carry going to get set. So this will happen. This is the answer for the 37 is the B. Next, moving into the 38. What is the value of frequency of oscillation for a unstable multivibrator having C1 equal C2 equal 1000 picofarad, R1 after 20 kilo? So solution. See, a stable multivibrator, the frequency of oscillation of the frequency of oscillation of a stable multivibrator is frequency of oscillation is 1 by time period. So 1 by time period is 0.693 times RA plus twice the RB into C. In this case RA equal to RB, that is R1 equal to R2 equal to 21. So in this case it will become 1 divided by 0.693 into 3RC, because R. Now substitute these things and all, you are going to get 0.693 into 3 into 20 R is 20 kilo ohm. 20 kilo ohm into C is the 1000 picofarad. When you substitute, you are going to get 24.05 kilohertz. See, there is no correct answer matching. 24.05 kilohertz. So answer for this question is no proper answer. You can raise the objection against this question also. Moving into the next question. The number of adder lines required for the 8 kilobyte memory chip in 8085 is, we need to connect 8 kilobyte memory chip, and if you see that 12 bit 2 power 12 will become 4096, 2 power 13 will become 8192. So it is 8 kilobyte. To connect the 8 kilobyte memory chip, we require the minimum 13 lines. So answer for this is D. Answer for this question is D. Moving into the next question. So consider an analog signal. Consider an analog signal x of a equal 5 cos 100 phi t. Find the minimum sampling rate to solve to avoid the aliasing. Solution. To avoid the aliasing, minimum sampling rate must be is greater than or equal twice the maximum frequency. But having only one signal, that signal having the frequency is, so omega has given 100 pi. So 2 pi f is 100 pi. F is 50. That itself the fm. The sampling frequency must be greater than 2 fm. So fs should be greater than 2 into 50, 100 Hz. This is f. So minimum, fs minimum is 100 Hz. 100 Hz. So answer for this question is option D. Okay. Wish you all the best to everyone. Thank you for watching my videos. Thank you. All your valuable comments are welcome. You try to give your feedback and valuable comments. Whenever I have a time, I will give it reply. Thank you very much. See you.